graph the system of inequality labeled the vertices. We first pretend to graph the system of equation. The first equation is x squared plus y squared equals 4. And we will use the solid line because of the equality within the inequality. The second equation is x minus y equals 0, where we would use the dashed line because of the strict inequality. We recognize that the first equation, x squared plus y squared equals 4 or 2 squared, represents a circle center at the origin with the radius 2. And the second equation is y equals x, where we isolate y to get y equals x is a line. And so 1 is the line that goes through the origin, and the other one is the circle centered at the origin with the radius 2. Realizing this, we would set up the coordinate system x, y axis with the origin. We then graph the circle x squared plus y squared equals 2 squared with the radius of 2. And we graph the line y equals x using the dash line, not the solid line, again because of the strict inequality. The equation of this line is y equals x, and the equation of the circle is x squared plus y squared equals 2 squared or 4. Since x squared plus y squared is less than or equal to 4, we will shade everything that is inside the circle, and so the inner circle. That is how we shade the first inequality, x squared plus y squared less than or equal to 4. Now, how do we know to shade the inside of the circle? We pick any arbitrary point that is not on the circle, such as the point x comma y, where x is 0, y equals 0, which is the origin, and we plug this into the inequality x squared plus y squared less than or equal to 4, and we checked. X is 0 and y is 0. Is this less than 4? 0 squared plus 0 squared is 0, and 0 is less than or equal to 4. Yes, this means this point is in the solution region, but since this point is inside the circle, we will shade everything inside the circle. Similarly, we pick any other point to determine the region that we need to shade for the second inequality, x minus y greater than 0. This line separates the plane into two regions. Ignore the circle for now. One is on the left or above the line, and the other one is on the right or below the line. To determine the solution region, we need to pick a point that is not on the line or on the curve. In this case, we pick any arbitrary point such as 2, 0. The point 2, 0 is this point here, and is not on the line. It is on the curve, but again, this is not on the line, and this time we only need to determine the solution region for the line, so ignore the circle for now. If we pick the point 2, 0, then x is 2 and y is 0. 2 is greater than 0, yes. And so the point 2, 0 is in the solution region for the second inequality. And since this point is on the right or below the curve, we will shade everything below this line. Now, the solution of the system of equation is the region that we shade twice. Notice that when we shade the inside of the circle, we shade the inside of the circle above the line and the inside of the circle below the line. But when we shade the solution region for the second inequality, we only shade it below the line. And so the part that we shaded twice is the solution region, and it is this part here. And to indicate that this is the solution region, we usually denote or annotate it by saying the solution region and we might want to draw an arrow to indicate the solution region for the system of the inequalities. Any point in the solution region in the part that we shaded twice will satisfy this system of inequalities.